Welcome back, fam. Today in Apollo EDU, I'm going to be showing you guys how to approach the first and second derivative test. And then I'm also going to teach you one of my favorite tricks I've learned throughout my entire college career, which is a trick to graph f of x from a graph of f prime of x. I'm excited to show you guys this lesson. So to start, we're going to work through the first derivative test. The first derivative test is super important because it tells us a whole bunch of valuable information. Still to this day, I use the first derivative test for lots of my engineering courses just to get an understanding of graphs and things of that nature. So the first step in the first derivative test is finding our derivative, f prime of x. Again, the derivative is just the slope of f of x, which is our function. So after we find f prime of x, we're going to set it equal to 0. So now we've got f prime of x is equal to 0, and we're going to solve for x. After solving for x, say we get two values that satisfy the equation to be 0, and we're going to call these points a and b. After we have these values, we're just going to put them on a simple line chart and have a and b, and then from there, we want to find the sign of f prime of x to the left of A, in between the 2 points, and then to the right of B. So now when we look at this, what this is telling me is that to the left of A, from negative infinity to A, f prime of x is positive. Between A and B, f prime of x is negative, it's less than 0. And then from B all the way to infinity, f prime of x is going to be positive again, meaning that f prime of x is greater than 0. So what is this information telling me? So when I have a function that goes from f prime of x is greater than 0 to then 0 at a, which we solve for right here, and then to negative, we're going to do the extrema dance. So we go from f prime of x is positive to 0 and then to negative. That's going to give us a maximum. So right here at A, we're going to have a maximum. Now if we look at B, we're going to go from f prime of x is less than 0 to 0 at B, and then it's going to be greater than 0 from B to infinity. So here, I'm going to be decreasing to 0 and then be increasing. So we're just doing our extrema dance. We're going from decreasing to 0 to increasing. So that's going to tell us that we're going to have a minimum at B. So an example of this graph, what we're seeing here, could be something like this. So we see that we're going to be increasing. Our derivative is positive. Then right here, our derivative is going to be 0. And then we're going to be negative between A and B. And then right at B, again, our derivative is going to be 0. And then from B going on to infinity, it's going to be positive again. So to summarize, what is this first derivative test telling us? It's going to tell us our regions of increasing and decreasing. So when f prime of x is greater than 0, our function f of x is going to be increasing. When f prime of x is less than 0, our function f of x is going to be decreasing. So right here, in the region from negative infinity to a, we're going to be increasing. In the region from b to infinity, our f prime of x is greater than 0. So again, we're going to be increasing here. But in the region between a and b, f prime of x is negative or less than 0, so our function is going to be decreasing in this region. The other thing that the first derivative test is telling us is our relative minimum and maximums. So again, when we go from f prime of x is positive to negative, we're going to have a max. We do the extrema dance to help us remember where we're going from positive to 0 to negative. And then when we go from negative to positive on the sign of f prime of x, we're going to have a minimum. So again, extrema dance, we go from negative to 0 to positive. This point right here, that's going to be our minimum. And we can see this on the graph where right here, this is going to be our maximum where we go from positive to negative. and then we go from negative to positive at b, this is going to be our minimum value. So this is just a gist of the first derivative test. Okay, so now we're going to unravel the second derivative test. The second derivative test is very similar to the first derivative test, but now instead of solving for our extrema values, our maximums and minimums, now we're going to be looking for our points of inflection. So the process starts the same way, where we're going to find f double prime of x, which is just the derivative of f prime of x, and then we're going to set it equal to 0 again. And then after we set f double prime of x equal to 0, we're going to solve for our x values. These x values are now telling us our points of inflection. The first derivative test, that value for x were telling us our critical points for extrema. Now these critical x points are going to tell us points of inflection. So after we find our points of inflection, we can again put them on a simple line graph and then find the sign in each of the different regions. So when f double prime of x is less than 0 or negative, we are going to be concave down. When f double prime of x is greater than 0, meaning it's positive, we're going to be concave up. So what is this second derivative telling us? It's going to tell us our regions of concavity. So where f double prime of x is greater than 0, we're concave up. How I like to remember this is I like to just draw plus signs and a little smiley face. So greater than 0, we're positive, so we're happy, so it's concave up. And then when f double prime of x is less than 0, we're concave down. So we draw this sad, angry face because we're concave down, and it goes down like that. Additionally, the point where it changes sign from positive to negative, that's f double prime changes sign from positive to negative or negative to positive, that's where we're going to have a point of inflection. So now I'm going to teach you guys one of my favorite tricks that I've learned throughout my entire academic career. We're going to be looking at about how to graph f of x when we're given a graph of f prime of x. So before we look at this, let's try and understand what a graph of f prime of x is telling us. When we're above the x-axis on an f prime of x graph, that means that f prime of x is greater than 0. Our function f of x is going to be increasing. Below the x-axis on f prime of x, that tells us that our function f of x is going to be decreasing. Also, if we look at the slope of f prime of x, which is f double prime of x, when this is greater than 0, like we learned just a second ago, our function is going to be concave up. When the slope of f prime of x is less than 0, so when f double prime of x is negative, our function is going to be concave down. The other piece of information that's useful is that when we cross the x-axis on f prime of x, that means when f prime of x is equal to 0, that's when we're going to have a critical point. So when we go from positive to negative, that's our maximum. So if we come across this way on f prime of x, we'll have a maximum. Whereas if we go from negative to positive, that's our minimum. So if we come across here, then we'll have a minimum. So here's the main trick, something that I learned a couple years ago that's super useful. So I'm going to break down the 6 categories of functions that will be super useful and super key to understand. So if I have something that looks like this on f prime of x, what this is telling me is that I'm above the x-axis on f prime of x, so I know that f of x is going to be increasing, and I can see that f prime of x is constant, so that means that I'm going to be increasing at a constant rate. So if I'm increasing at a constant rate, then I know f of x is going to look something like this. So I'm increasing at a constant rate, which is exactly what this is telling me. So the next one, which is very similar, is if I have something that's like this. So here I'm below the x-axis So f of x is going to be decreasing, and it's, again, a constant rate of decreasing. So on f of x, I'm going to get something that looks like this. Not too tricky. So basically, and if we go the other way, the derivative of f of x is going to be f prime of x. So the derivative of this is just this value right here. So now we're going to get a little bit trickier. So now if on f prime of x, I have something that looks like this. Okay, let's break this down. So I start out where I'm above the x-axis so that I know that f of x is going to be increasing. And I can see that the rate at which I'm increasing is increasing. Okay, also I can see that the slope of this line is positive. So the slope of this line is positive, so I'm going to be concave up. So this on f of x is going to look something like this. Okay, so now let's take a look at this. Okay, now I'm below the x-axis on f prime of x, so I'm going to be decreasing in f of x. I can see the rate at which I'm decreasing is getting bigger, so I'm getting more and more negative. And if I look at the slope of this is negative, so that means that my function f of x is going to be concave down. So now if I look at this, I'm going to get something like that. Okay, so the next case is if I have something that looks like this. So now f prime of x is above the x-axis, so my function is going to be increasing. But if I look at this, the rate at which I'm increasing is decreasing. I start out with a really positive slope at this point, but my slope, f prime of x, is approaching 0. So I can also look at the slope of this line, f double prime of x, which is negative, so my function is going to be concave down. So to combine all of these effects here, I'm going to get something that looks like this. So then the last case is when I have something like this. And now again, I start out with a really negative slope, a really negative f prime of x value, but my f prime of x value is approaching 0, so it's going to be leveling off. And again, my function f prime of x is below the x-axis, so that tells me that f of x is going to be decreasing. So f of x is going to be decreasing, and it's going to be concave up. So that's going to tell me something like this on f of x. So again, something that's another helpful way to look at this is where right here at this point, I've got like a 0 slope. My slope is close to 0 right here, and my slope is close to 0 right here. And then by this point, my slope is really positive, and you can see here, my slope is really positive. Same thing here. My slope here is basically 0, and then by here, it's really negative. And if we do it again, here, it's really positive, and then by here, it's approaching 0. And then one last time for this one, here, it's really negative, and then by here, it's approaching 0. So this is just a quick reminder, a nice little tool, so when you're looking at a graph of f prime of x, you can quickly have an understanding of what your function f of x is going to look like. I hope this was helpful for you guys, and I look forward to seeing you again soon.